hello. So we'll go over the questions you sent me, and then if you haven't taken your practice Unit 6 test, go ahead and do that. Okay, so this was the first one, question 4E in Unit 6, Part 2. So it asks you to find from 1 to 8 of f of t dt. And you're given the integral from 1 to 8 of f of x dx, that's equal to -2. And what this was really trying to show is that this variable x that you're integrating with respect to x, if we had changed that for the letter t, it actually wouldn't change anything. The answer would still be -2. So since it's the same function f, it doesn't matter what letter we're using for the variable. If we're integrating with the same limits, it would be the same. So that's just -2. Okay, 8a. Okay, now we're actually going to talk about all of these, or at least some of them. So here when we're taking the derivative, this comes from the first fundamental law of calculus. And so here this is saying d dx is saying take the derivative of this function that's actually an integral, t squared of this function dt. And what the first fundamental law of calculus says is kind of that the derivative and the integral kind of cancel each other out. So when we want to take the derivative of this integral where the variable's up top, all we actually do is plug in this variable for any of the variables in the function in what we call the integrand. So our answer here would just be plugging in x for the t. So we'd have x squared over x squared plus 4. That would be our derivative. Otherwise, what we have to do is we have to integrate this, then and put x in, and then take the derivative, which would give you the same answer, except we don't have a good way to integrate this. So that was part A. Part B would be very similar. You don't actually want to integrate here like you did, since we're taking the derivative of the integral. What we're going to do is we're going to plug this x squared in anywhere we have a t. So we'd have sine of x squared plus e to the x squared. And then the only thing to note, if this kind of little function or this expression up here in the upper limit isn't just x, we have to think of using the chain rule when we take the derivative, and we multiply by the derivative of that. So since the derivative of x squared is 2x, we would do that. And this isn't. Okay, so for example, for C here, we want the derivative of the integral sine of x to 0. Now what this is trying to show is that when the expression, the function is, sorry, these should have actually been, there are some typos here too. This should have been t squared plus 3t minus 1 dt. Okay, when the expression is down below, the first thing we have to do is swap it, put it up top. Now when we do that, we get a negative out in front. So then it'd go from 0 to sine of x. Then to take the derivative, we're going to leave the negative out front, but then we're just going to plug the sine of x in, so we'd have sine squared of x, since that's t squared, plus 3 sine of x minus 1, and then we have to multiply by the derivative of sine of x, so that'd be cosine of x. Okay, so that's those problems. Okay, so now we're going to go to section 4. So 4b. Oh, yeah, don't worry about 4b. It uses an extra like trig identity, so that would be one that like I would show in class, but don't worry at this point. It's not anything that would be on the level of the tests or anything. 6. Yeah, those look good. So okay. So these look good. You're right that C doesn't intersect here. Now these, I should have also put like y equals 0, the x-axis. So let's talk a little bit about D here. So if we want y equals 4 minus x squared, x equals -2, and x equals 3. And I should have had y equals 0, the x-axis. So drawing that, let's see if I can get fancy here. So here's our function, and then so we want to go from -2 to +3. -2 to +3, and I'm not very good at these drawings, honestly. This would come and like intersect, okay? So, and then we also want, that's not what I want to do, the x-axis. So, the area we're talking about here is this area and this area, okay? So, see how that kind of breaks it up into 2 pieces, the part above and below. So we're going to have to break it up into 2 integrals. So the first integral will cover this part. So from left to right, that's going from -2 to 2. So our integral will go from -2 to 2. Then we're going to take the function that's above, which is the 4 minus x squared, and subtract the one that's below, which here is just y equals 0 dx. So you could integrate that. Then we would add to it, this next part is going from 2 to 3. And here, the upper function is the 0. So we'd have 0 minus, and in parentheses, 4 minus x squared dx. So you would integrate both of those and add them together. So part F here, you're exactly on the right track. Your limits, which I think it looks like you had and erased, would be from 0 to pi. So of 2 sine of x minus sine of 2x. So when you integrate this, you would get -2 cosine of x minus plus, because it would be a negative and cancel out, cosine of 2x over 2. You'd plug in pi and then subtract, plugging in 0. Okay, and then this extended enhance is tricky. Now, the great news is you have shaded in exactly the right region. This region right here is exactly what you wanted to shade in. And so let me see if I can. So we have that one, this one. Now, notice this region, we actually have to break it up into 2 parts because which one's the upper function and which one's the lower function change. And so you actually do this integral where it's the square root function minus the squared function. Then separately, you would integrate this one where it's the line minus the square root. So nothing that complicated will be on your test or anything. It's just kind of show if you had a more complicated region of more than one intersecting, you'd have to break it up into more than one integral. Okay, so now this video only gives me 15 minutes and I don't want to take a ton of your time. So I want to go to this. So 18 was the first one you said. Oh, so 18, actually everything looks great. You did the chain rule, you did the quotient rule where you were supposed to. I think it's probably just a simplifying thing, but if you left it just like even this first step here, you would get full credit. So that looks great. Okay, 35. So it's asking, oops, from -1 to 0 of 3t over 3 plus t squared to the 4th dt. So your u here is exactly what you said it would be. U equals 3 plus t squared. So du equals 2t dt. So what you have looks good. So let's go from this step right here. So 3 halves -1 to 0 of du over u to the 4th. So we would think of that as u to the -4th, which would become u to the -3 over -3. We have this 3 halves. So you're right, you could cancel those out. So this looks great. And then plugging in 0. And then subtracting, plugging in -1. Everything looks great. I think you've done it. So I would check to make sure these parts are put into the calculator correctly. But all of your work looks good. 38. Sorry, that last problem was kind of me just rambling, but yes, looking at what you have, you've done all the correct steps. Okay, so again here it looks like, so you found that the intersection points were 4 and 1, which are exactly what you want to do. And then, so you set up the integral from 1 to 4 of, good, x minus 1 minus x squared minus 4, or yeah, minus 4x plus 3, good. So x minus 1 minus x squared plus 4x minus 3. So that looks good. So you combine the like terms there. Good. That's the correct. That looks good. So that all looks good. So then you would be plugging in 4 minus plugging in 3. So I have a feeling these are just because your answers aren't checking out exactly. So I would go through and check kind of your calculations, but your setup and your integration look great. So everything looks good. Okay, so don't hesitate to send me any more emails and or if you have any questions.